Hi, so here is the current state of the experiments I had when porting Crysl to MPS. So, of course, bear in mind that I have not encoded all of the Chrysl's grammar inside it. My main goal was to check whether I can harness the main advantages of MPS. So I'll go through the findings from my experiment by actually creating a Crysl specification. The first thing to remember in MPS is that in MPS you are not creating a program which is then compiled up, parsed or something like that. So when I create a Crysl specification, I'm essentially creating a node directly in the AST. I'm actually modifying the AST as I'm coding it, which gives me the first advantage of MPS, which is guided editing. So when some Crysl specification expert who has no idea or who has very little idea about the grammar, he doesn't have to learn a bunch of things about how to write specifications in Crysl. He just can use this guided editor, as you can already see. So the first thing is he knows that he'll have to give a name for his specification. Here, essentially, he can give whatever name he wants. Of course, here it's java.security. Yeah, okay, fine, whatever. And the next thing he would want to specify here is the usage. And as you can see, the editor is very guided in the sense that if I just press Control Space at some specific section of the editor, it only allows me to type what I'm allowed to type there. So it's kind of avoiding syntax error through the editor itself. So here I can either create an object or a var. So essentially the reason I have two kinds of variable here is that one is an object of a type that you've created, for example here a JVM type, and you can give it a name. Or here is another advantage of Crysl, or not Crysl MPS, is that I can compose languages on top of each other. For example, here I have kind of composed a variable declaration from another existing expression language. So that gives me free editors there. So yeah, I've created a couple of parameters. Now same with required block. Let me run through this bit because the interesting bit next comes with the order section itself. So with the events, I can create an aggregate or a method. So I can have one, I can give it a name, I can give it whatever name, and then I can here invoke the param2 and so on, right? Now, as you've noticed here, the auto completion and the syntax highlighting and things, for example, following the usedef blocks, all of them are kind of free with MPS. Let me create a couple of methods here. And then let me leave the parameters empty. And then let me create a bunch of aggregates here to test the order section. So this would be either M1. There is something wrong with the editor here, but it's fine. As I'm just let me create a couple of aggregates here. Three. Right now, in the constraints, there is not much bits interesting. As you can see, I have a couple of constraints encoded here. I can have an in or something. But the one interesting bit is that, again, as I mentioned, the guided editing. So when, for example, the user types in part, he doesn't have to know how the parameters are structured. He already has an idea what he has to fill in here. He can have a split, which is whatever. And then he can here say, I want to have param1. And then in this, and then he has access and so on, right? Now that's constraint. The interesting bit is with the order. The second advantage of MPS that I want to discuss is with the multiple notations and multiple projections that can coexist within each other in the same editor. I'll show you how I've tried to encode a state machine type of editor for the order section. Again, it's very primitive, so please, I apologize in advance, but here goes. So here I can actually type in one, yeah, I can, there is an error here because these are some of the small pains of projectional editing. 2, and then I can say whether it's multiple or optional. Here, let me say it's multiple. Now, the interesting bit here is that I already told you about multiple projections. So I've created a projection for having the Crysl order as a finite state machine. Of course, this is primitive and I worked on it only for half an hour or something. If I auto layout, I get another projection. Now, I can actually work with both editors at the same time by simply splitting the editor, and then in, for example, this editor, I remove the diagram editing part, and then now I have the textual editing on one side and the diagram editor on the other side. So for example, if I remove this part, I have the aggregate 3 removed here from the order, and I can add it back using the diagram palette. I can add an aggregate state here. I can point it to aggregate 3, and voila, and this is edited. So this is something cool about MPS, and it seems to be handy. And creating this simple version of the state machine took me like 20 minutes max. So the third advantage is also extending the languages created in MPS is pretty easy. And of course, finally, there is the required block. I can give it whatever name. Yes, and then the final advantage that I wanted to talk about was composing languages on top of each other. Currently, I couldn't find a meaningful composition of Crysl with one of the languages that already coexist in MPS, but I wanted to see if it exists, right? So for that, in this language, when it talks about an expression, the expression can actually be one of the reference expressions to these objects and events and stuff here. But at the same time, it can also be one of the expressions from the from a language that I can load here. For example, I can say expr.math. This is a language that exists in not an MPS, but my old company that I worked with had an open source language. For example, I can create a sum expression here, and then I can give it I is a number from 0 to 10, whatever, and then I don't know, it has, yeah, okay, fine. Now the point here is that, of course, this is not a meaningful use of this composability, but you can do it, right? So I think what would be cool later is to find out ways to meaningfully compose existing languages in MPS inside Crysl. For example, there is a version of Java in MPS, there is a version of C in MPS called Embedar, and there is a really cool functional language called kernel-f, which is what I'm using here. And then, of course, there is the ensures block, and then I can have another predicate here. This is probably going to throw me an error. Yeah, I can leave it. But of course, before I show you the generation aspect of it, I'll have to remove this use of a language for the use of a node that I don't have a generator for. But the last aspect is that currently, currently I have created a very simple generator which generates the Crysl file. So as you can see, it just generates a Crysl file that can be used in the normal workflow. What I plan to work on next is to create an extension to Crysl, this Crysl language, which incorporates MetaCrysl, and I plan to record the time it takes for me to encode this MetaCrysl. And the hope that I have is, because MetaCrysl has these configurations and feature models in it, there is already an existing constraint solver for these expression in MPS. So I'm hoping to reuse that, and hopefully I have a pretty cool MetaCrysl editor too. So bye-bye.